on capetalk.co.za,
on the app,
on DSTV channel 885,
and across the city on 567 AM.
Join the conversation.
This is Cape Talk.
This is Cape Talk.
Exactly what I needed to get this weekend started. It is time now for the Naked Scientist. We have a very special kids edition. Two schools represented today: West End Primary in Mitchells Plain and Pinelands North, which I think is quite self-explanatory. Why these two schools? Well, they're two Cape Town schools who've cracked the top 10 list for the best school in the world award. It's an announcement that's expected to be made in October, I think it is, but we're rolling thumbs and rooting for both of these schools. Ziad Noordin is a science teacher at West End Primary. Candace Van Sale represents Pinelands North. Ziad, can you hear us this morning? I hope you're well.
Loud and clear, Lester. Oh, you are.
Loud and clear. Candace, are you and the kids there?
Morning. We absolutely are and very excited to be part of the show.
Excellent. Can we have a scream, a shout, a yelp there from the kids in the background? Ziad, I'll start with you quickly first on just what it means for you and a school and a community to be nominated as the best school in the world.
For us, I think when the announcement was made, we were extremely excited, specifically not just for the school, but for the community itself. Because we're a school that prides ourselves on creating opportunities for our community, which is situated in a lower socioeconomic setting. So it means the world to us.
Candace, what about the kids at Pinelands North?
Yes, well, when we heard, it was almost like such an honor for us to be nominated to be the top 10. We're all very excited. And, as much as the teachers put in the work to create a loving environment where all the children can just be themselves, the children create the environment that everyone can feel belonged, a belonging, and who are unique in every way. So we were super excited to be nominated for this award.
And Dr. Chris Smith, the Naked Scientist, you must be feeling very excited this morning. Not only one school, but two schools and their kids to try and wreck your brain this morning. How are you doing, Chris?
I'm all right. Not just two schools, but two brilliant schools. I'm going to get pummeled from two sides here, aren't I? What are you doing? What have I done to deserve this?
Well, maybe in the future we can talk about the collaboration between a Cape Town school and a school where you are in the UK. Maybe we can take the Naked Scientist Kids Edition globally. But we have plenty of kids to get through. I think I'm going to do two at a time and jump from one school to the next. So we're going to be starting at West End Primary. Ziad, could you get Iman Tofar to come ask a question, and then also maybe get Caleb Captain ready to ask their first question to Dr. Chris Smith?
They're sitting on the edge of the seats waiting for him.
Excellent. Hello, Iman.
Hello.
How are you? How old are you?
I'm good. I am 13 years old.
13 years old. What's your question to Chris Smith?
My question is, what part of the brain do we use the most?
Brilliant. Good morning. Well, the answer is you need all of it. And the evidence for that is that your brain is so metabolically hungry, it's burning so much energy that if any of it wasn't 100% useful to you, evolution would have dispensed with it a long time ago. Now, to give you an explanation and some sort of facts to pin what I've just said on, your brain contributes about 2% of your total body weight, just 2%. But it burns about 20% of the energy that you are using at any moment in time. And a human runs at about 100 watts. So your brain is running at 20 watts. That's about the brightness of an average light bulb. And your brain is so metabolically hungry, burning energy at that rate, that if your body could do without any of it, it would have got rid of that bit over evolutionary time. So you need all of it, and you use all your brain all the time, even when you go to sleep. And you dream, especially, bits of your brain become incredibly active, and they're all densely wired together. There's 100 billion nerve cells in there, in the average brain, and each of them is connected to between 1 and 5,000 other brain cells. And so it's an amazing organ, and we are only just beginning to scratch the surface of how it works.
Thanks so much for that, Iman. Candice, while we get Caleb ready at Weston, could you get Jonah and Sophia ready? Caleb, Captain, how are you doing today, young man?
I'm fine, thank you. Yourself?
I'm fine, thank you very much. What's your question to Dr. Chris?
What is the proper term for the Adam's apple, and why is it informally referred to as this?
Hello, mate. Well, I think that the proper term for it is your larynx. It's your voice box, and the reason that it's referred to as Adam's apple, I think, is it's more prominent in men than it is in women, and this is why men have a different tonal structure to their voice. Men have a deeper voice than women do, because as we grow up and as we go through puberty and different bits of our body change their shapes, under the influence of the hormone testosterone, which is the male hormone, women have that too, but they have less of it than men. They have about 1/10 of the level of testosterone. Different bits of the body respond differently to the effect of that hormone, and one of them is the larynx, or the voice box. And the larynx changes shape and bulges and becomes prominent more in men, and that means you have a bigger expanse for the vocal folds or vocal cords, which are inside there behind what we call our Adam's apple. And because the cords are bigger and longer, they have a different frequency of vibration compared to cords that are shorter, like you have in women, because bigger objects will bounce or vibrate around with a lower frequency than smaller objects. And the frequency is the pitch. So if you have something running at a lower frequency of vibration, it will sound lower. And that's why men's voices are on average lower than women's are. And that, I think, is why we call them Adam's apples, because they become more prominent in men because men have more testosterone, and that makes that happen.
I think Caleb had a reason for asking that question, Chris. But let's go to Pinelands North now. Jonah Goldstein, good morning.
Good morning.
How are
Hello,
you?
my name good and you. My name is Jonah Goldstein. I'm in grade 3, and I would like to know what is inside of a seed that makes it grow upwards.
Jonah, the answer is that seeds contain everything that a plant needs to make a new plant. So there's something called the embryo in there, and that contains a set of cells, specialized cells, that know, in inverted commas, how to produce a baby plant. And from that embryo can come a new root and also a new shoot, which is where the first leaves will form. But also in the seed, and in fact most of the volume of the seed, is the stuff which it uses as its energy supply. It's like a backpack on the back of the embryo, a battery pack full of power. And the seed dips into that and uses that energy supply to produce its growth and tissue until it can produce its own energy from its leaves. So it's a bit like when we send a probe to Mars, there'll be a battery supply on the probe, and it will power the probe until it gets down onto the surface of the planet, puts its feet down and opens its solar panels, and then starts collecting energy from the sun itself. And so a seed does the same thing. It's got the energy store in there, which is starch and proteins and so on, to power the initial germination and growth until it can unfurl its solar panels called leaves or petals, and they then start to capture the sun's energy. So basically, seeds are amazing things. They are in suspended animation. The plant is effectively sleeping until the right trigger comes along and tells it to wake up, and that can be a snap of cold, and the change in temperature then says winter's been here, now it's spring because temperature's going up again, germinate. And other plants are even more intriguing because they have a chemical trigger that makes them wake up. And in South Africa, but also in Australia and other places where there are frequently bushfires, plants have evolved to respond to the chemicals produced when wood burns, and they use that as the chemical trigger to know that there's been a bushfire recently, and now's a really good time to grow because there won't be very many other plants competing with you for light and water.
Thanks so much, Jonah. Sophia Hassim, how are you doing, young ma'am? Young ma'am, not man. Hi, Sophia.
I'm good, thank you.
I'm a girl.
My name is Sophia Hassan, and I have a question, which is, why is there more than one planet if we only live on one?
Good morning. Well, the reason there are multiple planets around our sun is that about 5 billion years ago, that's when our solar system in other words, our clutch of planets, began to form. And they all formed independently because there would have initially been a big ball of gas and dust hovering in space. And we think that about 5 billion years ago, another star, a bit like our sun but bigger, nearby, reached the end of its life and exploded. And when it exploded, it made a shockwave, like a bomb going off, that buffeted the cloud of gas and dust that was where we are, and it made it push together in such a way that it began to fall together into a big ball, which became our sun, and that was called a protostar. And around that ball was some of the other gas and dust that was attracted into a ring around that protostar called a protoplanetary disk. Because of gravity, the material all forms a disk, a bit like the rings around the planet Saturn. And over time, more and more of the gas and dust began to attract together, and the planets formed out of that gas and dust. And because there was lots of it, and a big distance between where the star, our sun, was forming and the outer reaches of that pile of gas and dust, there were lots of places where planets could independently form. And slowly, through gravity, they pulled together all the material near them until it was all used up, pretty much, making the planets that we have today. And that's why all the planets are in a line in our solar system. If you imagine a flat sheet of paper, that's called a plane, all the planets line up in the solar system in that way. They all go round the sun at different rates, but they're all in the same flat plane, going out from Mercury, closest to the sun, right out to Pluto. If you call that a planet, we call it a dwarf planet these days, that's the farthest away that we know of at the moment.
It's the Naked Scientist Kids Edition. 2 schools today. Why, you may ask? Because West End Primary in Mitchell, Spain, Pinelands North Primary, they've both been nominated as the best school in the world. So we're doing a double header today with the good kids from those schools, asking Dr. Chris Smith the tough questions. Michaela Swat and Kelly Maritz, get ready there at West End Primary. Michaela, how are you doing?
Good morning, I'm good, thank you, yourself.
Fire away.
My question for you are there any parts of the human body that gets oxygen directly from the air and not the blood?
Oh, hi, Michaela. Well, the answer is yes. And I don't know if anyone in your class wears contact lenses yet, but contact lenses are in direct contact with one part of your body that absolutely gets its air oxygen supply from contact with the air, and that's the front of your eye. And that's why you have to be very careful wearing contact lenses, because if you put a barrier between the front of your eye and the outside air, you can starve that tissue of its supply of oxygen. The cornea is the front part of the eye, and it's completely clear so that light can go through with nothing getting in the way, so we can see clearly. The problem is that in order to make sure there's nothing in the way, that means you can't have blood vessels. So the cornea does not have blood vessels running through it. That's why we have such good vision. But if you don't have blood vessels, you can't deliver oxygen like you can around the rest of the body. And that's why our cornea relies on being in close contact with the outside air to get its oxygen supply. And when you wear some kinds of contact lenses, you can get some called rigid gas permeable lenses, and those ones have tiny holes in them so that they can make sure that air can still get through and oxygen can nourish your cornea. Because if you don't have enough oxygen getting into your cornea, then it can make it run out of oxygen. Cells can become harmed and they release substances that make blood vessels grow. The posh word for that is neovascularization. Try and say that when you've had a few. And as a result of that, it does cause your vision to become cloudy. So we don't want that to happen.
Candice Van Zyl at Pinelands North. I'm going to ask you to get Bantu and Reese ready. But up next, Kelly Maritz from West End.
Good morning.
Hi there, Kelly. You may go ahead. Fire away.
My question to you is, how many suns are there?
The answer is that in our solar system, there's, of course, just one. We call it the Sun, but it's our nearest star. But we're in the Milky Way galaxy, which is a big sort of aggregation of stars, and we think that there's something like 100 to 200 billion stars, some of them like the Sun, in our Milky Way galaxy. But then there's something like 100 billion to 200 billion galaxies like the Milky Way out there as well. So if you add all that up together, NASA estimate that there's something like a sextillion stars out there in the universe. It's about 1 followed by at least 22 zeros is the number of stars out there in the known universe. So the answer is too many to count, because if you started counting, you wouldn't live long enough to count all of them.
Excellent. Candice Van Zyl, a teacher at Pinelands North Primary School. Is Bantu Kweza ready there for us? Good morning, Bantu.
Yes, he is. Morning.
Excellent.
My name is Bantu. I am 7 years old. And I would like to know, why do flowers only bloom in spring?
Thanks, Bantu.
Hi, Bantu. The answer to this one is, I suppose you got to step back and say, well, why do plants make flowers at all? And the answer is flowers are the way that plants reproduce. They attract pollinators, or they allow the deposition of pollen, which are the plant equivalent of sperm, onto the plant's equivalent of eggs in the ovaries. And flowers are pretty, they have colours and patterns, they're also scented, and they're a supply of food, because inside the flower there's very often the supply of nectar, which is the sweet sugary substance that the plant puts there, and this attracts pollinating insects that will come in, and in return for a warm treat of nectar, they will pick up some pollen and drop some pollen off. And this is how you trade genetic material between plants, because in the same way that you have children, if you're a human, plants have children by insects bringing pollen from one flower of the same type to another. So why do it at the springtime? Well, why do it at any time? The answer is, if you make your flowers when no other plant of your species is making its flowers, it's impossible for the pollen of other members of your family to get to you to fertilize you. So the plants have to make sure that they all flower in synchrony at roughly the same time of year. Otherwise, that pollination process won't happen efficiently. And so therefore plants have evolved to flower at certain times of the year, and many of them flower at the time of year when the most pollinators will be around. And so it makes sense for most plants to flower at roughly the same time of year when most of the pollinators are there, because that way you maximise your chances of you getting pollen from another member of your particular plant group, so you have maximum chance of making lots of seeds, so you can make sure that you make more of yourself.
Chris, there's a real diversity in the questions that are being asked today. I'm really, really impressed by these kids. But Reese Barent at Pinelands North, how are you doing?
Good.
How old are you, Reese?
7 years old.
7 years old. What's your question to Dr. Chris?
How big is the galaxy compared to another thing?
Hello, Reese. The Milky Way galaxy, which is the name of our galaxy, is about 100,000 light years across. So in other words, if you stand on one side of it and you shine a light, and we know how fast light travels at 300,000 kilometers a second. So in other words, if you shone a torch on Earth, it would have enough time to go around the Earth 10 times in less than a second. That's how fast light travels. But our Milky Way galaxy is so big that if you shone a light from one side of it, it would travel for 100,000 years before someone on the other side of the Milky Way had any chance of seeing it. That's how big our galaxy is. And that's why, being as it's that big, there is room for a couple of 100 billion stars like the Sun to all fit together in there. And there are hundreds of billions of galaxies like the Milky Way spread out across the universe. So it really is a massive place.
We're running out of time, and I really want to get through all the kids that we have here. So, Ziad, I'm going to ask that you ask Malik and Amir, Malik Pinar and Amir Brainers, to ask their question together. Hopefully we could squeeze in Mujahid. I know kids are disappointed when we don't have enough time, and also Candice or Luca and Kamuhelo to ask their questions together. We're going to try and squeeze them in. So Malik and Amir, good morning.
Good morning.
That was cute. Go ahead, Malik.
My question is, can bromine melt obsidian?
And Amir?
How did life begin?
Oh, two
We need
simple
a bit
ones
more
there.
time than
I
6
love the
minutes.
way that you've just said, well, let's get through these quickly. Bromine is one of the halogen elements in the periodic table. It's a bit like chlorine chemically. It's smelly. In fact, the name bromos in Greek, it means stench or stinky, because bromine has a strong smell. it won't in and of itself do anything to the substance known as obsidian, because obsidian is volcanic glass. It's effectively where you've heated sand to a very high temperature and made sand melt into a glass. And we keep acids and other things and alkalis and other chemicals in glass because glass is really hard to erode. The only thing that will eat glass is hydrofluoric acid, which is more reactive than bromine. Fluorine's the most reactive element that there is. And as you're asking about bromine rather than fluorine, the answer will be no, it's not going to do anything to obsidian. Now, how did life begin? Really interesting question and impossibly hard for me to answer, although I will share with you. I spoke yesterday to a scientist in America, a Frenchman. He's working in California, and he has just discovered the world's biggest bacterium. Now, most bacteria are how we think life started, actually, as a single-celled, tiny, microscopic things, a fraction of a millimetre across. And bacteria are about a thousandth of a millimetre across. These bacteria that he's discovered living in the Caribbean are 2 centimetres long. And you can pick them up with tweezers. They are massive. Isn't that intriguing? And you can find out more about that story on The Naked Scientist this week. But in terms of how life actually got started, we think it got started pretty early in Earth's history. Our planet's about 4.5 billion years old, and we've got evidence chemically of life on Earth from about 4 billion years old. So when the planet was only 500 million years old, there's evidence we already had life flourishing here. And we think it probably got started initially as just chemical reactions where you've got one particular chemical that makes more of itself. And over time, this became a bit more specialized to make something that was a bit like DNA, our storage molecule that keeps information. And as that became even more specialized, it evolved ways to make bubbles around itself to control better the environment that the substance was in. And that became the first primitive cells. And then those cells, about 500 million years ago, teamed up and began to join together to make what we call multicellular life. So instead of single-celled bacterial cells, life became multicellular, where cells teamed up and worked together rather than in isolation. And that is what ultimately gave rise to more complicated life, like plants and animals and ultimately us.
Kamohelo will be our last question this morning. I wish we could somehow find it in Chris's busy schedule to devote an hour. But Kamohelo, you have the final question today. Good morning.
Hello, my name is Kamohelo, and I'm in grade 1. And my question is, what is the moon made out of?
Wow,
Jeez, right.
Another great question. The answer to this is that the moon is made of the same stuff that the Earth is made from. And the reason that is the case is because the Earth formed about 4.57 billion years ago. So 4,500 million years ago, we had the Earth. And the Earth smashed into another planet that was about the size of Mars. And in the collision, lots of stuff from the surface of the Earth got thrown up into space and surrounded the Earth and then slowly coalesced or joined up together to make the moon. And we know this because you can compare with rocks that we've recovered from the moon, thanks to missions like the Apollo missions. You can compare the chemistry of the rocks we've got on the moon with what the Earth's made of, and we can show that the moon is made of the crust or outer coating of the Earth largely. And that's, we think, the only way we can explain for that is that there must have been a big smash up in space that put lots of the Earth's surface material into space, where it then turned into the moon.
Lucas, Setas, Mujahid Davids, unfortunately, we've run out of time. If there's any fairness, I get to disappoint at least one child from West End and Pinelands North. But here's what I'm going to do. You're going to send your teacher, Zihad and Candace, going to send Amy a voice note with your question. We're going to send it to Dr. Chris Smith. Chris Smith, you don't mind sending us a personalized answer for Luca and Mujahid?
Depends what they want to know, Lester, but I'm sure I can do
And
that.
also, Chris, you're confirmed. Many people want to know from you, not just about your big brain, but also why you do the thing you do. You're on air with us at 11 o'clock on Monday. You're in the chair. We're going to be talking a little bit more about yourself. Maybe you can squeeze in a science-related question. I'm really looking forward to Dr. Chris Smith in the chair here on the morning review at 11 on Monday. Thanks so much for agreeing, Chris.
All right. See you next week. And brilliant questions today, guys. Really, really good.
Excellent.
Kept me on my
And
toes.
to Ziad Nurdin, Candice Van Sale, and the kids at West End and Pinelands North Primary School, good luck for being nominated as the best school in the world. You guys and the kids make us really, really proud. Thanks so much, guys. Really appreciate it. Good luck. Bye-bye, kids.
Thank you.
Thank you.